All right, so today we are looking at finding the inverse of a 2 by 2 matrix, okay? So in order to find the inverse of a 2 by 2 matrix, first of all, let's talk about what an inverse actually is. Okay, so let's go back to our regular old numbers, okay? Well, we're talking about just regular real numbers, and we're talking about adding together, okay? What an inverse is it's individual to each number, and it's something that when you add them together, you get the identity. Okay, so we know that when we talked about addition, we said that our identity number, right, was zero, because if you add zero, you always stick with the same number, right? So with the inverse, if you have, say, the number three, then with addition, the inverse of that number is a number that when you add it to three, the answer is zero, your identity. So in this case, negative three. So three and negative three are inverses. Okay, if you have, like, say, negative 17, right? What number do you add to that to get you back to the identity of zero? Well, positive 17. Okay, so the opposite sign numbers by addition, that's what your inverse number is. When we talk about multiplication, and again, just with regular numbers, we said that our identity was one, because when you multiply anything by one, it just stays the same. So when we talk about multiplying an inverse, if I want to multiply 3 by something, I'm looking for a number that when I multiply it by 3, I get 1 as an answer. So that's what the inverse is. So the inverse of 3 is the number that when you multiply it, the answer is 0. So 1/3. Okay. So if we were talking negative 17, right, what do I multiply by negative 17 to get back to 1? Well, 1 over negative 17. Okay, so these are your inverses for these different operations. Now, when we're looking at a matrix, it's a little bit more complicated. Okay, so to find the inverse of a matrix, a little bit more complicated just because there's a little bit more to it, right? There's a lot more to the multiplying step to figure out how do I get it to multiply to our identity. We know that our identity would be like something like this, right? We talked about those. Okay, so the question is, what do I have to, like, I have a matrix and I have to multiply it by another matrix so that my answer is going to be that, and it can be a little bit tricky. Okay, so that's what we're looking at today. So first of all, just some basic stuff. So an inverse matrix is something that you multiply a matrix by in order to get an answer that is an identity matrix. Okay, so it's the matrix you multiply by to get back to an identity matrix. Okay, and then the rule is that it must be a square matrix. Okay, we talked about how identity matrices are only square matrix. Well, in order to find an inverse, it's also got to be a square matrix. All right, now there is a long way of doing this out, but we're going to take a shortcut method. Okay, so this is sort of like the quadratic formula. There's a process that somebody went through and they did it with some letters to see what happens in the final answer. And this is what you do. Okay, so this is like a quadratic formula in that it doesn't make a lot of sense if you just look at it, but if you just plug the numbers in, it'll always work. Okay, so let's take a look at this. So the first thing that you're going to do is you find something called the determinant. Okay, so you find the determinant of the matrix. Oops, I missed an N. NT. Okay, and the determinant of the matrix, like if this is our matrix, so it's A, B, C, D, right? You multiply these two numbers, and then you subtract the product of those two numbers. So you're multiplying the numbers on the diagonal. So it's the two things on the main diagonal minus the two things on the minor diagonal. Okay? All right, then what you're going to do, so we multiply that determinant, right? That goes here, goes in the bottom of my fraction. Okay, then what we're going to do is we are swapping the numbers on the main diagonal. So it was A and D. Well, we're switching it, so it's going to be D and A. Okay, so we're swapping the numbers on the main diagonal. Okay, and then you're changing the signs of the other two numbers. So this was a positive B and a positive C, and we made it a negative B and a negative C. Okay, it's not always going to be a negative number, though. It'll be the opposite. Okay, so we're changing the signs on the minor diagonal. Okay, great. So let's take a look at an example here. So this guy right here, we want to find our example. So first thing we're going to do is find our determinant. So the come on, marker. Sorry, that marker doesn't want to work. All right, so the determinant of our matrix. This one doesn't work either. Sorry, I'm using a different bag of markers, and apparently several of them are dead. All right, here we go. So the determinant of our matrix. Okay, so I'm going to multiply the numbers on the main diagonal. So it's 4 times 6, and then minus the product of the numbers in the other diagonal. So 2 times 7. So that's 24 minus 14, which is 10. So 10 is the determinant of my matrix. Great. Okay, so now we figured out the determinant of our matrix. So now what we're going to do to find the inverse is you're putting 1 over the determinant, so 1 over 10. And then we're going to multiply that by, I'm taking this original guy, and the first thing I'm doing is I'm swapping the 4 and the 6. Okay, so the 6 is now going to be up here, the 4 is going to be down there. And then I'm going to change the signs on the other two numbers, so -7 and -2. All right, and then the last thing we're going to do is we are going to distribute this. So 1/10 times 6, well, that's going to be 6/10, right? Which I can simplify to 3/5. 1/10 times -7 is -7/10. 1/10 times -2, -2/10, but that simplifies to -1/5. And then 1/10 times 4 would be 4/10, but that simplifies to 2/5. Okay, so make sure you simplify your fractions. Okay, and that is your inverse matrix. Okay, so that's your inverse matrix of this whole thing. So if we called this guy matrix A, right, then this, the notation for it, you see that little -1? That's a symbol for an inverse. So we'd say A to the -1, the inverse of matrix A is that. All right, so it's not too awful. I spared you the trauma of doing it out the long way, and we just went with the shortcut method. So let's call this one matrix B. All right, so again, first thing we do is we find our determinant. And to do that, you multiply the two numbers in the main diagonal. So that's -20. And then you subtract the product of the minor diagonal. So that's -16. So -20 plus 16 is -4. So my inverse is 1 over -4. And then times, swap the two numbers on the main diagonal. So -10 and 2 goes there. And then change the signs of the other numbers. So this is going to become a -4. That's going to become a +4. You're not swapping those two. You're just changing the signs on them. All right, and then we distribute. So -1/4 times -10 is +10/4. But I can simplify that to 5/2. -1/4 times -4 is -4/4, which is +1. -1/4 of 4 is -1. -1/4 times 2 would be -2/4, which is -1/2. So that is our inverse matrix. Okay, and that is how you find the inverse of a 2x2 matrix. Now, like I said, this is the shortcut way of doing it out. The long way involves solving using your Gauss-Jordan elimination with an augmented matrix, and it's kind of a pain in the butt. So as I'm sure you could guess, this only works for a 2x2 matrix. If you wanted to look at, say, a 3x3 matrix, then the shortcut process is much longer, and doing it out would be even longer than that. So we're just going to worry about doing 2x2 matrices out by hand.